All right, so welcome back. Now, this question deals with the titration calculation that we see so frequently, right? Once again, once you read the question, we need to highlight. You can use it pencil, underline it, or anything that suits you. So, 25 cm cube of sulfuric acid is neutralized, and exactly 22 0.5 of 0.2 mole per dm cube sodium hydroxide is used. Calculate the concentration of the sulfuric acid in mole per dm cube. Okay, so we need to calculate the concentration. Now, first and foremost, we need to calculate the moles of a substance whose all of the information is given. If we look into sulfuric acid, the volume is only given. Right now, a lot of students make this mistake. According to my experience, is they use this volume into the equation mole is equals to volume divided by molar volume, which is obviously wrong because sulfuric acid is not a gas, it's an aqueous solution. We need its concentration as well, which we need to find over here. So obviously that equation is not going to help us. The another equation that deals with aqueous solution is volume into concentration divided by 1000 if the volume is given in cm cube. Now you see the concentration or the information of sodium hydroxide has been given fully. So we will be using the information of sodium hydroxide to calculate the moles of sodium hydroxide. So mole of NaOH is equals to volume times concentration divided by 1000. We do this divided by 1000 because the volume has been already given in cm cube. If it were in dm cube, we would not have to divide it with 1000. So if we plug in the values, what do we get? 22.5 times 0.2 over 1000. The value that we get is we get 0.0045. In some of your calculators, it might be in standard form, which is 4.5 into 10 to the power minus 3 moles. Now, either one works, okay? So we know the moles of sodium hydroxide, but we need to calculate the concentration of sulfuric acid. Now, we can always find the moles of other substances in this equation if we know the moles of only one substance. In our case, we know the moles of sodium oxide. So we will be doing the molar ratio with sodium oxide and sulfuric acid. Now, if we go to the molar ratio of sodium, sulfuric acid and sodium hydroxide, 2 moles of sodium hydroxide represents 1 mole of sulfuric acid. So 1 mole of sodium hydroxide is going to represent half moles of sulfuric acid. So this is going to be our factor with which we will be multiplying, right? Therefore, mole of sulfuric acid is half times moles that we got. And the value is 0.00225 mole. It's better that you take the information in 3 significant figures. That will give you more appropriate answers, right? Now, we know the moles of sulfuric acid, which is this, and we also know the volume of sulfuric acid we used, which was 25. Now, if we tweak this formula over here, mole is equals to volume into concentration divided by 1000. And if we subject concentration over here, the new equation that we get is concentration is equals to mole times 1000 divided by volume. We get the following result. Mole is 0.00225 times 1000 over volume, which is 25. If we calculate this value, what do we get? We get 0.09 mole per dm cube. Okay, so the concentration of sulfuric acid is 0.09 mole per dm cube, which has been neutralized by 22.5 cm cube of 0.200 mole per dm cube sodium hydroxide. I hope this helps. In the next one, we will be solving another equation that involves this balanced equation. See you guys in the next one.